These are the bolts that are whipping up a firestorm of controversy and concern. The New York State Attorney General's office confirming. So I have to do narration, or they can make me take down my video. The unfair use laws. So this is the bridge. This is the only video I can find of it at this time showing the bolts that are in question, specifically using this OK symbol in the background. And we'll get to that, and I'll skip the video. I'll skip some of it. It is investigating the alleged use of faulty steel bolts during the construction of the $4 billion Governor Mario Cuomo bridge. According to published reports, some 60 bolts broke apart during the building of the bridge, along. So 60 bolts broke apart reportedly during the building. So they broke in tension. We think they're not saying whether they broke in shear or tension. It appears that when they're applying, or what they're saying is that when they were tightening the bolts, they broke in tension. So I'll show you that. Here we go. With allegations, the state's contractor tried to cover it up.
Well, that's a little scary.
The opening of the bridge back in September, just before the primary election, which replaced the old Tappan Zee Bridge, was billed as an important infrastructure achievement for New York Governor Andrew Cuomo. But the new revelations are now raising questions and concerns over. So that's a specific bolt. You see, it's A490, and that's an in. That's an in. A490 in. That's important for you. Hold on. Why the bolts failed, and whether the contractor tried to hide that information from the New York State Thruway Authority, which maintains the bridge.
It's alarming.
Okay, so we can pass on that. Let me put my earpiece back in, my mic, and maybe that'll be better for you guys and myself for the video. So let's keep that data there for a moment. And let me make sure you guys can hear me. So I need a quick sound check. It's going to be about 20 seconds, guys. If anybody's there, it's only a couple of people watching. So a sound check. I know I just jumped right into the video without waiting for anybody. Sound check. Can anyone hear me? Please test. There we go. Testing 1, 2, 3, 4. 1, 2, 3, 4. You know what? I can sneak do it this way. Let's see if this gets it up. There we go. Testing 1, 2. Yeah. Moving on up. Thanks. Thank you, Auburn Blue 64. So now we jump over to, let's talk about the bolts and testing. Here's your in. That's an in, as you saw it in a different shape, a different character type. This is an ASTM A490 bolt that they're referring to. This, you can find this online yourself, things like this. You'll find it under all types of different characteristics. It's going to be a standard bolt. Now, in is a bolt that's subject to shear. Shear is, let me see if I can get you guys a better idea of what shear looks like. I have a bolt picture here. So shear would be one going this way, this anywhere you want. It's just slicing it in half, but not like a knife going through it. It would be one side stationary and the other side stationary. Imagine your fist on one side of this and your fist on the other side, and then they were close together, and you're able to push one fist forward and one push up and one down. That would be your shear action. It's not a knife. The problem with their testing that they're doing on the bridge, that they apparently are doing on the bridge with that, what I showed you the video where you see, that's another bridge video, where you see the OK symbol.
Since it was replacing a bridge that was supposed to be dangerous.
A source for the New York State Thruway Authority tells me that in early 2016, there were concerns about, quote, a very small number of bolts, and that independent experts. So you see the OK symbol there? The OK is what they're using to say these bolts passed. Now, they're looking for visual inspection if they're all in the same location, if the plate is tight here against the back of the rest of the girder, or whatever this member is, this truss plate is tight. It appears to show no movement, but all the bolts are in place. There's no shear taking place. Well, shear would take place on all the bolts simultaneously in theory if all the holes in the plates are 100% lined up. So you couldn't tell if it's failing in shear at this side besides looking for movement of the plates around it. You see if it's moving. And you would see openings here and things like that. So it's pretty tight. So these are in shear. These are, hold on. Then you have your shear bolts. You have your slip critical bolts. Those are SC, and your X bolts, which are also going to be your non-shear related bolts. So that would be, and going back to that, oh, it's over here, right? Over here, missed it by a tab. Bear with me. Bear with me. And this video is going to be short. Oh, I guess I missed it right next to it. That's the video. Great. I just lose my bolt video. Okay, so it is a high quality bolt specifications. It's leaving me, what, 1 or 2 left? 1. Great. So shear is going to cut through like that. When you're doing testing, though, to test these bolts, so now they've said that they put those bolts you saw had the OK symbol on them. Well, the OK symbol would be what I just generally described to you, and they could put a torque wrench on it and see if it meets the same torque as it was supposed to be applied torque. But that doesn't resolve. That is not good testing of those bolts. That to me would, with the doubt that they're having, that's unsatisfactory or not satisfactory. Because if we look at testing of bolts using the Federal Highway Administration's high strength bolts procedure for performing rotational capacity test, this is on the A490 bolt, the short size bolt, or the long size bolt. I would think that's a long size bolt. It just shows you how to clamp it differently. What you're going to find is, so you're back here at the same thing. Here's your test. You're testing for the A490 bolt. I can bore you with a little bit of that, but let's cut to this. Loosen and remove the bolt, the nut. This is after they're put it through this load, if you will. There shall be no signs of thread shear failure, stripping or torsion failure. No twisting, torquing. Imagine a bolt when you're tightening it that it could actually twist. The nut shall turn with your fingers on the bolt threads to the position it was during the test. So after you take this apart, sorry guys, I bit my tongue or something like that. I don't know what's going on. I think the dentist, when she was doing cleaning my teeth, she hit my tongue. It was numb at the time, so I wouldn't have known. So it's giving me a little bit of a lisp. These bolts, you would just be testing them for, well, they still have the same torque, but that's not the issue. The issues are they structurally sound bolts. You'd have to take these apart, each bolt individually, look at it per using this test, and if you were to do that, and you would put those bolts back into place, surely each bolt would have been individually tested at that point. That would be great, but you would also mark off each bolt individually on the head if you were to do something like that. You wouldn't just do OK here, general OK, because you would lose track of what was your next bolt. Were you going down? Were you going sideways? Which way were you going? And you'd ideally mark them with like a magic marker, something like that, here to there, tagging it, so you can even see if it's rotating. At this point, you're here now. You might as well mark it to see if you can check for rotation. They have tags and things like that could do that. Okay, so now for this test, for them to say these look good, that's terrible, I think, because you should, if you have doubts about the bolts now and 60 of them failed, you should be taking them under this test here. Yeah, it's going to be awesomely expensive and time consuming to do it. But they just checked it for torque and location and non-movement of the bridge. It's just general stuff. I think it's not released exactly what they did, but I do not see them doing this. Now, when you do this test here, I'll explain to you. The nut shall not need to run the full length of the threads. If you cannot turn the nut with your fingers, it is considered a thread failure. So when you're tightening a bolt, it actually elongates, but it can come back to its position if you don't pull too hard. Let me get you the last page again. So this is what's elongating. So when they test it, say it's tested out to right there, under load, under their tension test. Then they take the bolt off. They take it away, separate it from what they had, the spacer here, the plate. They take it apart. Then they want to see this screw back into that point again without any stretching on the backside, etc. And you want to inspect it as it's shown here. You'll see no torsion, no rotation of that. Show no signs of thread shear failure, stripping, or torsion failure. So there'll be nothing. The bolts won't show any stripping of the nut back here, and changing, deforming these threads. There'll be no sign of that. That's what's more important. Back here, you won't see too much failure. It would be out here more than likely, because it's a thinner machined section, is where it really gets questionable. So they had 60 bolts that had this type of failure in it, or popping, however they failed. They probably popped and the bolt just kept spinning. And at that point, they knew this was a failure. And I don't know how they accounted for the bolts, but they came up with 6 zeros so far. And maybe they had to reorder bolts. Who knows? No, but you can lose bolts, but they accounted for them. So that is using the Federal Highways standards. And I'll give you some links for this, guys, so showing you how other people refer to testing methods of bolts, 39 pages. And also shear now. So this is showing you that how you initially, one of the tests, how you initially snug it up, the percentages when you're doing the application of it. Now it's going to make sure that you do not allow these bolts to get under shear while you're torquing them. You don't want that. So they use a spade wrench. I'll get my wrench wrong. I think it's a spade wrench. Well, my brain's a little twisted now. To allow it, so when you're tightening these bolts, that the plates, the two plates that you're tightening together, one is not just resting on the bolt as you feed it into the hole, that it will be free spinning. You could take your finger and rotate the bolt. So ideally, if you're looking at their If you're looking at this, I should ideally be able to take the nut off the back of one of these and rotate this freely. If I can't rotate it freely, it's under shear. It's a simple trick that I use for a lot of things with being able to, if it's under load. So you should be able to undo one bolt of this and rotate it freely. If you cannot, then that bolt was under shear, swelling, compression, contact, whatever it might be, however you want to call it. But it has contact at that point, and it's under shear. You can remove one of these and no love lost, and you would have to go through every one of them. So you would do that little simple thing like that. Undo a bolt, see if you can rotate it by hand, inspect the bolt for its elongation, put the bolt back on it, the same nut, check it out, put it back. Yes, you'll need somebody on this side and somebody on that side. And you need something to catch the bolt so you do not lose a bolt, so you don't ruin your testing. They have all the bolt heads up on this. It apparently, those are bolt heads up. And yep, those are the not the bolt heads, those are the nuts. It appears to be the nuts. So that water can go down here in between these threads. If you've ever seen anybody play with lubrication test and things like that, to see if the lubricant will get around these threads, you can see that happen. So that's kind of it makes it easy probably for inspection. But now we have all of them facing one direction, facing up. So you would ideally like to cover that to protect it against salts and things like that going down the thread. So that's just like a common sense thing there. And of course, the loads equal on each side of this nut. Nut and bolt are equal in theory. Okay, so, and the nut's compensated to be equal with that. What else can I share with you? So here's the link, here's the sizing of it. That was an idea to give you an idea. And what am I missing here? This is the testing again. This is using the Federal Highway Administration testing. So if they didn't pull every bolt out, they did not test those bolts fully to satisfaction of myself. You don't have to satisfy me at all, right? But hopefully this video will get out there and other people will scream, and they can do their own resources, pretend like they found it for the news or whoever wants to use this, and say, well, this testing is inadequate. It's inadequate. Yeah, it's cost savings, but it's terrible. All right. Oh, okay. Yes. Finally. So if you had those bolts, if you were torquing those bolts in to the plate, and they were in contact with each other, then you're ruining the threads, because as it's turning in, it's now threading into using the connecting member, as it gives you a false sense of torque, and then the backside wouldn't be tensioned enough. So that would be the same thing with this. So if I loosen the bolt and it couldn't rotate, well, I'm getting a false sense of torque when I do try to torque this, because even without a bolt on, it's giving me a torque amount. And could you do ratio? Could you do percentages and say, well, it's a swollen? No, I don't want to go for that. It's not part of the highways testing to allow for that. And this video will terminate now. It was short. I just want to explain that and see if you guys say anything. Another accident waiting to happen. Yep. Happy holidays. Hello, Danielle. So this one is, in my conclusion, is what you can make of it. What you can make of it. The testing is not adequate. It's not adequate. And Cuomo Bridge bolt failure explained and questioned. And I'll drop some links here as I terminate this video. Oh, I like the Christmas tree. How'd you do that, Danielle? How do you do a Christmas tree? I guess you got special status. So we'll follow up on this. I'll try to get some data from this as soon as it's released and follow up on their bolt testing. How is their bolt testing performed? Which company performed it? Was it a private company? Was it the state coming back out there checking it? It's under load, guys. All those bolts, I mean, some of those bolts are definitely under load at this point. So I don't get their testing method by the bolts being in place and testing them. You're going to get false torque numbers to see if they're actually applying, and you can't tell how the failure is. I mean, we need to know how the 60 bolts failed. You know, did they all fail like I roughly described in how I theorized they broke in the backside of the bolt thread? How did these 60 bolts fail? They're all consistent. I mean, you've got a nice lot there, LOT, a nice lot of them, and to investigate the failure. And, you know, it's amazing. All right. So manufacturing, etc. So this is me saying bye on Google Hangouts. Merry Christmas.